Technology will forever be changed by the invention of 3D printers. Everything from a paperclip to car bodies can now be created by the printers quickly and easily. Some people are predicting 3D printers can even end world hunger. Someday soon, people will be able to construct whatever they can dream up using 3D printing technology. And one of the critical ingredients to manufacturing new objects is having the blueprint for whatever you wish to create. Earlier this year, plans for a 3D printed gun caused outrage. Gun control advocates breathed a sigh of relief that the plastic gun was not a fully capable metal weapon. Such a design was impossible without a new technological breakthrough. Many people say that the printers could not create metal parts strong enough to build a full-fledged handgun. But now, an all-metal firearm that can be produced on a 3D printer is a reality. This could forever change the distribution, registration, and ownership of firearms in this country. The new design was developed by Solid Concepts Incorporated. That company is a leader in the field of 3D printing. We're joined on the show today by the Vice President of Additive Manufacturing at Solid Concepts. His name's Kent Firestone. He's here to talk to us about the new gun as well as the technology behind 3D printers and the future of the industry. Welcome to the show, Kent.
Thank you. Glad to be here.
Kent, why did you decide to develop this new gun amid the controversy from the gun designed by Defense Distributed?
Well, the idea to build the gun was actually just kind of a little side R&D project. We've been for a number of years doing components for some of the major gun manufacturers in the U.S. and we earlier this year acquired our Type 7 FFL so that we could legally make serialized components as well. And once we got that, one of the main project engineers, and his logical next step was, well, let's just build a firearm. So it started out as just a side R&D project to see what would happen. Once we found out the gun was, worked and held up to the pressures and stress involved and everything, at that point we really didn't know what to do with it. We just kind of said, "Ooh, isn't that cool?" and set it aside. And then our marketing team got a hold of it and said, "Oh, we have to get this out there and get some exposure for the process and the technology." And so that's kind of how this all came about.
Talking about the technology on a very basic level, how do 3D printers work? In this case, you used use metal components.
That's correct. This is an industrial scale 3D printer. I mean, we call them additive manufacturing or rapid prototyping machines, but it's basically a powder-based process. Start out with gas atomized metal powder, whether it be stainless steel or nickel alloy. And you take a three-dimensional CAD model, you slice that into very thin 2D cross sections, and then a laser draws at each cross section and melts. So everywhere the laser's touching in the powder, it's melting the powder. And then you just do that over and over until you just stack layers one on top of the other.
So how is this process different from the plastic printing process?
Mainly, well, the actual process is a little bit different. We use a laser and powdered metals here. The plastic printing process that most people are familiar with uses an extruded filament. So you have a thin filament of plastic going through a heated extrusion head. And so what it's doing is it's like a plotter. So it's plotting down the filament, and then it cools and solidifies. Most of the 3D printers that people are aware of use that technology.
Now, how did you come to decide on the specific firearm you chose to print?
Well, mainly, we knew it was an open source model because, all the patents had expired since it's a 100-year-old design. And we felt it would be easy to find the files online. So sure enough, we were able to find them. And so that was part of it. The other part was that this design has a lot of metal components in it. So we figured it would be a really good opportunity to showcase that kind of regardless of the stress or regardless of the application of the metal, we could get them all to go together and function.
Now, did your gun, was the model you produced, did it fire on the first shot, the first one off the line, no problems? Or?
Yes, the first test fire was actually the lead-in on that original video that was released with the string. And so they did two, vice-mounted test fires using a string to pull the trigger from 10, 12 feet away. And then once that happened, we went straight to somebody holding it and shooting it. So it was probably not the world's longest testing cycle, but we saw what we thought we needed to see. And I might add, we had a lot of faith that we wouldn't have any problems, because we make metal components that go into just as high of stress applications as what that barrel is seeing. So, and we haven't had issues there, and we've done quite a bit of R&D to look at the porosity of the metals and things like that. So we had a pretty good idea that it would be fine.
Now, you use some off-the-shelf components like the clip and the spring, I believe. Is that correct?
Yeah, the springs, the magazine, the screws for the grips, and there's a stamped steel piece on the inside. We bought that at a local gun shop.
But the barrel, you said, the barrel was actually created using this 3D printing process.
That is correct.
Fascinating. How much does it cost to produce a firearm this way compared to buying or producing a similar model?
We don't have a firm number. We're still trying to kind of put those numbers together, but it's probably 10x of a high-end, probably 3 to 5x of a high-end gun. So like a Gold Cup 1911 by Colt's, probably in the $4,000 range. We're probably a little bit higher than that on cost. Maybe 5 to 6K, but we're not real sure. We're still trying to put those numbers together.
Kent, we're up on a break, and I want to come back and discuss if there's any backlash from the gun control community. I want to discuss with you possibilities of government changing registration process because of this new technology. But like I said, we got to take a break. Stay tuned. We're talking with Kent Firestone of Solid Concepts right here on WHDT.